Okay, great. It is recording as well. Okay, let's get started then. Thanks everyone for attending. This is going to be a special session. We're doing a bit of community brainstorming. It's been requested many times. And yeah, let's open up the floor. If you have anything you want to work on, you want to see being worked on, the future of the project, any feedback on the project, any ideas, feel free to throw it in. We're going to record this meeting and I'm going to take notes as well in the regular meeting notes doc. I just linked it in the chat. And I'll keep on admitting people. But yeah, feel free to get started. I'll open the floor to anyone who's interested. Don't be shy. You can just raise your hands.
Here, I'll.
Yes, go ahead.
I'll get started with something pretty small and tactical. The V3 spec allows us to promote date types to timestamps. This is something that the Java implementation actually hasn't done yet. We should also do it.
Gotcha. Yeah, so there's a bucket for all of the things we have to do for V3 spec. I think there's a big issue open. We can just add it there, but taking some notes on it too.
Yeah, I'm personally very excited about server-side planning. I think it's going to be big.
Server-side planning, yes. I think all of the sub-projects are taking up that dependency for server-side planning. I think we're trying to add the server side or the catalog side to the Iceberg REST fixture, right? On the Java project, which all the sub-projects depend on, and then we'll have a reference to interact with.
Especially in combination with like the find rate access control. So with server-side planning, you don't need any access anymore to the manifest, which also contain like lower and upper bound, which is also like sensitive information.
Right.
That's especially like if you're working in like a sensitive environment, that's going to be cool.
Who's next? Kaushik?
Yeah.
You have your hands up?
Hey, yeah, I just wanted to ask. So I've been working with the geometry and geospatial with Iceberg. I saw that that's going to be implemented in like it's already implemented in Parquet. It's pushed to PyArrow in the C++. I think it might be helpful. I know that there's some discussions in Iceberg. But I was wondering how that support will look like and what the timeline will be for that release in PyIceberg. Because I saw that there's an issue already, 1820. But I don't think it's been worked on yet, or there's a PR in progress.
Yeah, I can take that one. So geometry type is part of the V3 spec, which means the Iceberg table version V3. We have a bucket of items to do to support V3. This include read support, write support, all the different types. And it's a work in progress, I would say. For that one specifically, I haven't looked at it, but in order to support geometry type, which is part of V3, as a project, we have to support reading and writing V3 tables. Does that make sense?
Yeah, I got that. And has that been worked on? Is there like an issue or like an epic that I can track for that?
There is. If you look in the issues tab, I think there's an epic for V3.
Oh, I see. 18,
tracking
18.
issue, yeah. So we have a few different ways of doing it. There's a tracking issue. There's a tag. I threw it in the notes.
Okay, perfect. Thank you so much. And I had a follow-up question. I know that there's going to be tighter integration between Rust and Python. I know that Poco, you talked about it during the Iceberg Summit. I was wondering what that timeline looks like and what kind of stuff to expect, because I know about like it's good to have it like parity between all these clients.
Yeah,
What is the timeline? Yeah.
I think the first step is going to be like the alpha readers, of course, and hopefully more. But yeah, I think it's a pretty long road because we also see like some gaps in Iceberg Rust that we have to fix. Because I think in majority, like PyIceberg is a bit further along, and yeah, it's very hard to tell people like, oh, we switched over to Iceberg Rust for some parts of the things, and it's faster, but at the same time, we cannot like break things, right? So we cannot say like, oh,
Yeah.
it's not working anymore for that reason. I think it's we just see like where the gaps are and try to fill those in and see if we can adapt a lot of the stuff that they're developing there, because it doesn't make sense to build things twice, right?
Yeah,
Thank you.
I linked an issue on the notes too. It's an epic to track PyIceberg and Iceberg Rust integration. It is in the Iceberg Rust repo, which is probably why you haven't seen it. Maybe I'll move it also to the PyIceberg repo. I don't know. It's hard to keep track when it's between projects.
Yeah.
But over here, we've listed some of the ongoing items and ideas. I think the main one Falco said already, it was the alpha readers.
Okay. And are you looking to take contributions for it? Or is it like something, because I've helped with like the unknown types, so I'm happy to help push this along as well.
Oh yeah, 100%.
Okay.
Yes, Alex, go ahead.
Hey, just kind of a follow on there. I saw this issue in the Iceberg Rust specifically for the size of the PyIceberg core binary. This caught me as well when I upgraded to 0.10.0 and pulled up PyIceberg core to the latest. Just in terms of like I was using it in a AWS Lambda, and that increase in the dependency size like pushed my total zip size above what is supported by AWS Lambda. So it's not the biggest deal in the world, because I could just refactor to use a Docker image Lambda instead of a zip-based Lambda. But I was curious if there's any thought going into how much of the Rust library is being pulled into the PyIceberg core and the effect on that resulting binary size.
Yeah, I can talk about it a little bit. I think what happened here was originally there were only a few functions being exported through the Rust binding. I think when I added the data fusion provider, it pulled the rest of the Rust code in, because it pretty much needed everything in the Rust package. So then that's what caused the size to go up dramatically. But I guess a question for you on like the use case is, what were you using the PyIceberg core for specifically? Because that binding was originally like the intent of that binding was originally for PyIceberg as a submodule so that we can delegate some features. So if you were pulling that directly, what were you using it for?
I wasn't using it directly. I'm using the PyIceberg, like the Python library, to just write to a table.
I see.
I guess I thought that I needed the PyIceberg core dependency to do that.
I see. So PyIceberg by itself was not hitting the limit, but PyIceberg plus PyIceberg core went beyond the limit.
Well, I was using PyIceberg core my understanding was that we moved the implementation of like the transforms to the Rust implementation. And like in PyIceberg core 0, I think it was 0.4.0, I had a Lambda function that was using PyIceberg 0.9.1 and PyIceberg core 0.4.0. And that was all, hunky dory. And just using that to write to a table when files land in an S3 bucket. And then I just updated that to 0.10.0 and the, 0.6.0, 0.7.0. I can't remember what the latest PyIceberg core is. And when I tried to do that, I ran into this size issue. So it was just unexpected. It's not a huge deal.
Gotcha. I mean, so from your perspective, you're just using PyIceberg and all of a sudden you upgraded and it became bigger than the limit for AWS Lambda.
Correct.
Right? And then the kind of, you dug into it and it was PyIceberg core. That's interesting. I wrote down some notes. Let me take a look at what, I'll create an issue. Let's see like what the size limit is, because I know a lot of folks who are using PyIceberg are using it in the Lambda. And if there is a way we can cut down on the size, I think that'll be good for the end users.
Yeah, definitely. It's not all PyIceberg core, like I'm using Arrow, which is itself a massive
Yeah, I mean, I feel like if you look at the real estate, PyArrow probably takes up a lot of it.
Yeah, so it's more just like the change pushed it over the limit.
Gotcha. Yeah, that makes sense. Cool. Anyone else? Yeah, go ahead.
Yeah, so I think like two huge things to have. One is like a major like sort of polish or like finisher of just like being able to modify schemas and sort and stuff. It's kind of a bummer having to submit like a Spark job just to like alter the schema of a table, at least in my workflow, which I think we can do in PyIceberg. I'm more thinking about the sort order PR that's up. So I'd love to put some eyes onto that. And then additionally, I think another huge like step for the library will be concurrent Python applications, being able to write to a single table, which I think is in the works. So again, I'm calling out that I will try to use my brain power to for those two things. I think the biggest one there is the delete file index PR that Drew has up. So I'm happy to get some eyes on that and other things. But I think that'll really like broaden use cases for the library.
Makes sense. I put make it easier to modify tables, so DML. Concurrent writes. I guess it's not concurrent write, is multi-threaded process. Right?
Or I guess like the validation checks, because I have some teams with some ugly retry logic.
Yep, and that one's next. Commit retries, and then the delete file PR. Alex?
Can I just ask a follow on, like what the strategy is for those commit or the thinking for those commit retries? Because like right now I just have it in a retry loop that uses table.append over and over again and catches the whatever table modification exception. And that works great, but my understanding is that like each time I call append, it's doing like the full upload of all the data files and everything. So throughout that series of retries, it's actually like duplicating or triplicating, et cetera, the data that gets written to the bucket rather than just retrying the commit on top of the latest manifest version.
Yeah, that makes sense. That is the kind of simplest way to do retries, right? And there are a lot of optimization in the retry strategy. I think one that I've seen recently was cache, or not caching, but saving in memory the metadata, the data files metadata, so like stats and everything. so that when you do add files, for example, you don't need to recompute the stats. So I think there are a lot of optimizations that we can do there, but I think the biggest one is probably how the client and the server interact and how you can make that process, like make that commit retry process simpler, or I guess more optimized.
Yeah, totally. Like I'm just using table.append right now rather than add files, and all of the like partition logic, create the data files and everything, that's all like completely abstracted from me. I don't believe that I get any information back about those individual files. So I can't build something smarter that then like tries append, gets back a list of data files, and then like if it fails on the commit, then try to use add files later on. It would be awesome if the PyIceberg library just kind of abstracted that retry logic for you, and you could pass like timeouts and retry counts and jitter and things like that for exponential backoff. I think that'd be really powerful. And then similarly for deletes as well.
I wonder if this is all something the transaction manager can handle. Like I was thinking about from like a function level for add files, for example, right? You kind of have to restart that entire operation. But for something like a transaction manager, it's like all or nothing, right? And this is where it can be smarter about like the current state of the table, what to do. Because like for something like add files, and when you're appending the files, it's all metadata operation, right? So as long as you can work solely on the metadata operation, things should be a lot faster. Yeah, I'm just spitballing here. I have one I want to bring up, which is there are a lot of PRs stacking up, and sorry about the wait for, I know a few people are waiting for reviews. I think overall, for like the general health of the community too, I would encourage more people to review PRs, review each other's PRs, just kind of take a stab at like looking at some of the code that's in flight. I think it'll be super helpful to have more eyes on the PRs that are already pending. I think we did a really good job of encouraging people to contribute, and now we're bottlenecked a little on the reviews. So let's encourage more people to do the reviews, and then to kind of speed up some of the development, because I know we've been talking about some of these for a while. Suffering from success, yes. Anything else anyone wants to talk about?
I can just bring up the API RFC doc and just remind the folks in this larger group. So we've been talking about creating a 1.0 release for PyIceberg for a long time, and I think based on the amount of users we have within the community, it is about time. One of the biggest issues we've run into is the challenge in maintaining backward compatibility within our APIs, and we've had a lot of great suggestions the community has brought up so far. A very popular suggestion is to use a more strict convention for introducing public APIs than the informal convention of using uppercase letters, or not undercased letter in the front, right? So like this approach will require you to specify an underscore all field within each module in it file what the public API is. And I describe a set of steps to do this in a sizable, like incremental, progress-driven approach without having a single PR introducing the target state across all of the modules within the entire project. I just wanted to get a few review feedback before I actually started working on it. But if there's no concerns, I can start working on some of the modules, create some reference PR implementations for how we can actually go through this exercise so that different individuals can also take up like one or two modules that they want to propose changes to and break up the work and start making progress. If you see the stats on the RFC, it's literally like 3,000 or so like public APIs that are reported on the project right now, which makes it very difficult for us to manage the project. So we want to reduce this surface area of our public APIs significantly so that we actually just keep the APIs that are being used by our typical engineering end users, as well as other open source projects like FTP or Daft or any others that want to integrate with the internals of PyIceberg. That's the link.
Yeah, I added that to the notes as well. Sorry, I haven't been able to take a look, but 100% in support. I think it makes sense to me if we do it piecemeal, because otherwise it is a lot to figure out like which one goes where. I see that in the doc there's already kind of modules and separation, so maybe we can like move one at a time and then have CI to like allow list that one specifically and say, hey, like from now on, this module is set in stone and all the APIs are public, and then we can move one at a time. I think that migration story feels easier to deal with.
I would just remove that thing and leave all of them.
Sounds good. I'll get started with some PRs and maybe we can work from the bottom up.
Yeah, and something like catalog, table, the schemas, the transforms, those are all very logical like public APIs. I'm very interested to get into like file IO. I always wanted to make PyArrow and FSpec just the same, or like not have users specify which one to pick, because I think PyArrow and FSpec also is interchangeable from reading the docs. And like if you look at the Java implementation, you specify which underlying storage. You don't specify which implementation of file IO, right? I say Hadoop file IO. I don't say like this flavor of Hadoop file IO. But that'll be interesting when we're looking at it from like a public API standpoint.
I'm hoping to remove a lot of the service by removing the Avro stuff. I think it will already like cut down the number at least pretty significantly. Yeah, easy win.
All right, sounds good. Yeah, let me actually create or there might be already an issue for it. I'm just gonna like start working on it. Maybe we can publicize the number of APIs that are exposed just to kind of track progress. And maybe we'll start with the Avro one, just like you said. That might get folks excited.
Anything else anyone wants to add on this topic? Okay, I think as a good segue, I want to talk about 1.0. And I think the PyIceberg has a lot of features, a lot of usage. I think it's a good time to start talking about what it means for 1.0 release. I think maybe the best way to go about this is a checklist of what we need to do to achieve 1.0. I think one of the things the last time this conversation came up, one of the things we talked about was having the API stabilization, right? That's kind of what 1.0 signifies the most, right? Is that these the libraries mature, these APIs are mature and stabilized. You can depend on this set of APIs. So that's one of the items. I think another one might just be like features and what features we want to provide. I think there are things that are still missing for like V2 tables, right? Like the deletes, the positional deletes, writing positional deletes, all of those. Those are kind of less of a priority when I think about 1.0, but it is good to have to signal, hey, like this this library is mature enough for all V2 tables. I think that's like a nice nice feature to have. Along the way, you know, all of the metadata operations. I think at this point we have a full set of inspect operations, which is awesome. Yeah, anything else anyone can think about?
I think related is the idea of like laziness. I was contributing to the Rust one, and I think Micah left a good comment there that instead of like materializing the inspect tables, we should return iterators. And it made me think of, are there other like places in PyIceberg where we should be lazy before finalizing on 1.0?
I think in general it was a pretty good approach that we followed with the blend files, and also it was like a recent PR that actually made like the upsert lazy, where we actually don't pour everything into memory right away, but we actually stream through the batches, which was pretty impressive if you looked at the number of the memory pressure, because I think that's also one of the main issues with the inspect table, right? Like they can grow pretty big in memory especially and take long to load. So yeah, I think that's a great idea actually. Yeah.
I have an open issue, I think, that tracks a couple of the laziness stuff. I think one for inspect and then one for paginating and listing tables, views, namespaces, etc. So I can add to that other places it might make sense to be lazy.
Yeah, cool.
And is this for evaluating the metadata files as well as the data files? Like the laziness approach, like lazily reading the manifests as one part of it.
Yeah. So instead of just like, for example, inspect, like reading the entire rest table and returning that, just like,
Right.
return an iterator that can get consumed.
Gotcha. Yeah, that makes sense. Cool. Anything else anyone wants to talk about? Yes. Luke, go ahead.
Hi, I guess I just wanted an idea of like the direction that the package is going in terms of like the Rust bindings being just like dropped in where we want optimizations. Is it still going to say like Python on the exterior? Or is it going to be like, could it eventually end up as just completely thin shim on Iceberg Rust, like just bindings basically?
Anyone wants to take that? I have my opinions.
That's a good question. I'm not sure where it's gonna end. Yeah. I think the idea was always to have like a fully Python package, but yeah, that's very limited, right? If you do everything pure Python with no native bindings, especially for the low level stuff, like, and that's why we also introduced like the site and the Afro reader.
Yeah, we've been on our side, we've been looking at like performance of loading tables, and yeah, we've seen like an absolute ton of time being spent like basically parsing the manifest. So even after you've done the Avro read, just doing that parsing where the manifest list is quite big is really slow. And it's like to the extent that just the sheer number of objects is triggering the like Python GC pretty intensely. So yeah, obviously like that's a perfect candidate to go into Rust. But yeah, like the longer term view, is it just Iceberg Rust is where the development should go, or?
I think especially we also have a lot of so there's the metadata path, but I think especially also the path where we actually read the parquet. We have a lot of visitors that we do like a lot of post processing on the actual arrow buffers, and that's also extremely inefficient. Yeah, so if you can, I think that would be also good content to push down into the Rust layer. Yeah, I would love to see that.
Yeah, I think Alex just added a comment about like the 1.0 release and the public interface. I think that's what I wanted to mention too, is that I think in the ideal world, if I snap my finger and all of Rust is implemented, and we can take that to go on the PyIceberg side, I would like to use it as much as possible, given that we have a good interface for exposing that. And what I mean is, when I look at PyIceberg, I think of it as one is a utility, right, for interacting with Iceberg table. Two, it's a library for others to build on top of. And by that, I mean having good interfaces to interact with components of Iceberg and all of its constructs, right? So for Avro manifest reading, for example, that's a good abstraction, right? Because either you have to go parse the Avro manifest yourself, or you can use this function that extract out exactly the right schema and the right data back, right? Give you a data model that is Iceberg based, give you the function to read into that, and as a user, as a builder of whatever in Python and Iceberg, that's what you would expect. So I think that is the state I want to see, right? Which is we have a good interface, and then afterwards, underneath, the implementation can be in Python, can be in Rust, can be in probably not in Python, but you get the point, right? Like after you get a good public API going, the implementation we can optimize on the Rust side. There's a lot of interest in Rust. I love it. I think that reminds me of something I wanted to talk about, which is all of the compute-like and database-like functions that we're adding to the library. Merge into is a great example, right? It is a very tedious, I don't know if that's the right word, but it is difficult to implement. It's difficult to get right. It's difficult to be feature complete. And in all honesty, Python is not the best to do those operations. And I think there's a way maybe we can offload some of the heavier compute to an engine-like thing, right? Like one way we can implement merge into is if we have zero copy, right? Arrow buffers, throw into DuckDB, get the results back. Like have a engine who is specialized in dealing with this kind of operations to do the heavy lifting, and the library itself just delegates. Now that's just me spitballing. I don't know if we actually want to implement it that way, but I think the general idea is for a library is not its core competency to do engine-like things, right? So it might be better to offload that somewhere else. Yeah, Alexander.
Hey, sorry, this is much really just my naivety about PyIceberg, but building on the back of your comment of making PyIceberg something to build tools off of. How is the sort of test fixtures side of things on PyIceberg? I noticed within your code, you seem to have something where you start something up in the background. Is there any direction to sort of like make nice and easy to use, like in-memory catalogs we can connect to for testing? And it may exist and I'm just ignorant to it, so sorry.
So you're asking specifically about for builders of Python and Iceberg, like ways of doing integration tests?
Yeah, well, more unit tests. So like just something.
Yes.
Like right now we are building in-house tools, and it would be super useful if there was a sort of standard fixture to use to be like, bring up fake catalog, put these namespaces, these tables, and like let me test my custom function I built off the back of that. But yeah, I don't know if that's within scope.
Yeah, that makes sense. Anyone wants to take that? Otherwise, I can. Alex, I know you just added something in the PR for integration tests.
Yeah.
Okay. Yeah. I mean, you can go ahead.
No, you go, and if there's anything else, I'll add stuff in.
Yeah. So the current set of tests in PyIceberg, there are two. There's the unit test and there's the integration test. And the difference is for integration tests, we spin up extra services, right? We spin up a REST service, we spin up a Spark service, and this is just for testing the project itself. For the unit test specifically, there are ways of spinning up a catalog object that is not dependent on anything else. So in the code base, there's something called an in-memory catalog. You can use that. It creates a in-memory SQLite database. It gives you a catalog Python object back. I don't think it deals with concurrency really well, but at least you have you can create an object without depending on external services. So that's one part of it. The second part is if you want to test against, say, a REST catalog, the project itself actually gives you a nice template for spinning up a REST service through Docker, right? It's part of our integration test suite. If you type in like make test -integration -setup, it'll spin up a Docker container of these services, and then they run on localhost and you can interact with it. And then Alex just added something to the integration tests where you can specify your own catalog implementation where it is, and the integration tests will test against that specific catalog integration.
Awesome, thanks. Yeah, that pretty much does it.
And yes, we need to improve our docs on this because the in-memory catalog was added a while back, and it's very useful in testing scenarios. Cool. Anything else?
So is the plan to kind of turn all of these into GitHub issues after this?
That's a good question. I think that's a good idea. I haven't for some of these there are already GitHub issues associated, but for some of the other ones that are newer, we can turn them into a GitHub issue. I think generally for this meeting, it was more about like what are gathering, what are some of the ideas and things that people are thinking about, top of mind. I think maybe for something like 1.0 milestone, it's worth it to add an epic just to keep track of the state. I feel like people who are not as part of this meeting will eventually want to look for it, and searching the issues page is probably step number one. So just taking that and putting it over there will be a good idea. Does she have anything to contribute, Vaco? Anything to add?
Some great bugs, I think. Was er wat tussen? No.
Cool. Yeah, I think the only thing top of mind for me is just encouraging more people to review. I think we're currently bottlenecked on some of their reviews, and there are a lot of great features that are currently in flight, and it'll be really good to kind of have that as part of the library. And in terms of the release process too, I think that's a good one to add. 1.10 took a long time because various factors. I think it was like 6-7 months in between. So I think it would be a good idea to set a cadence for releases. I think when we talked about it last, it was like a 3 months cadence, and that's like kind of the upper bound. Is to say, if we want to release faster, we can, but if not, 3 months is good to release a new version, get it out there in the world, and have people use the new features. I think this is the same process that other sound projects has adopted, and it just it makes it so that we're not kind of withholding a bunch of issues, bunch of features that we want to kind of release together. Cool. I think this is very productive. It is recorded. I think I'll post it on the YouTube channel, the Iceberg, Apache Iceberg YouTube channel, and then others who are not here can look. And yeah, if there's nothing to talk about, I'll give you guys 5 minutes back.
Thanks.
Cool. Thanks a lot, everyone.
Thank you. Have a good week. Bye.
Great seeing you, man. Bye-bye.